right, we're rolling.
Got it? All right. All right, we're hot. Everything's good to go. Let's see if it does it again.
Are you aiming at anything?
Hey everybody, this is Andy with modernmilitaryhistory.com. Yeah, I'm not planning this to be a gunsmithing channel, but it is a gunsmithing project today. I promise to come at you with more varied content in the future, but right now we're looking at a Gewehr 98, and this one's really a nice rifle. I got it on Gunbroker about a year ago. And I've been wrestling with a undisclosed problem that this rifle had at the time of sale, because I don't think the guy who was selling it ever pulled this thing apart. And believe it or not, this rifle has been Duffel-Cut. Let's repair that and show you guys how it is done. Okay, so I've already gone in here, and what I did was I squared off the ends of the Duffel-Cut. The Duffel-Cut had occurred right in here where the front band actually protects the that little piece. So whoever cut this thing thought that, you know, his cut would be hidden behind the front band of the rifle. Unfortunately for him, let's see if I can show you here. Duffel cutting a rifle stock is never as simple as just cutting it and then gluing the ends back together. As I can show you here, all saws have a definite diameter, which means the blade itself is a certain thickness, and it eats through wood by turning that thickness of wood it is in contact with its sharp edge into dust, which means that millimeter or so of wood is gone. And when it comes to something like a firearm, you have pretty tight tolerances in terms of making things work. Everything is perfectly measured, and if you cut out even a millimeter of wood, things like your front retaining band and your bayonet lug and all these little index holes, they're just going to be a millimeter off. So it can actually be quite a project bringing one of these guns back. So what did I already do? I went in, and even though it was just a millimeter of wood that was cut underneath this front band, I took a piece of walnut after I'd squared the ends down, and I used that front band as a spacer. Let me see if I can show you. I got a whole barrel of parts back there. So I use this front band as a spacer to figure out just how much room, there we go, I was going to need to be able to put these two together for them to line up. I used the original spacer to show me how much wood I was going to need from the back engaging portion of this locking spring, this retaining spring, to the rear face of this rifle stock. I figured out what diameter of wood I was going to need to replace by using this guy. So I ended up just removing all the way back to this shoulder of wood and then replacing it with a new chunk of walnut. And as you can see, it's looking pretty good, and this was actually fully repaired. I'll put in a picture now of what this thing looked like when it was all together. And what happened, I had a little retaining bolt up here, but that wasn't enough. I took this rifle out to shoot, and I put 25 rounds of full load 8mm mil-spec FMJ through this guy Just shot it downrange, and everything appeared okay after shooting. But what had happened was this little guy actually had a mushroom head, you know, another couple of millimeters forward, that's still embedded up here in this channel. You can see I created a little channel in the barrel cut out up here, the barrel channel, and just glass bedded in a little dog bone. And what happened was that little metal guy was not enough to withstand the full recoil of 8mm Mauser. So he snapped, he's gone, and as you can see, this is just a clean little nubbins, and there was no mechanical function, there was no mechanical connection here holding the forend to the rest of the stock. And this guy just moved this way, and I actually just recently took my rifle all apart again to do some maintenance on it and checked, and sure enough, this front glue joint, which was just a chemical bond without the mechanical dog bone in there, that chemical bond had failed, and this guy was just about to crack off on his own. I did the coup de grace. It is done. But it's okay, because all the hard work is done. I've already measured out this piece right here. This has already been measured. Everything works. Everything fits. So all that is done. So now I need to go back in and just reattach this front end to the rifle stock. I'm probably going to just clean up these faces, just run a file over these guys and square these back up because they got crusty old glass bedding glue on them. I'm using Brownell's glass bedding. It is called, it's this stuff, Brownell's Acroglass, and this is really good stuff. It's for glass bedding though, and any chemical bond when you're trying to create a mechanical function, such as holding two pieces of wood together, chemical bonds such as a glue joint just is not enough. Ask anybody who builds anything from shipbuilding to gunsmithing. You never rely on glue and glue alone to hold something together, because under the laws of acceleration in physics, especially shooting that kick-ass 8mm full metal jacket military load that this rifle was designed to shoot, this forend, especially once it has the bayonet lug on there and the rest of the metal, this thing has a lot of weight that all of a sudden wants to go that way, the way of the bullet. So this needs to have a really strong mechanical bond, and what I'm going to use here is I'm going to use glue to create a chemical bond that enables a mechanical bond. So how am I going to do this? What I'm going to do is I'm going to take these two machine screws. These guys are about 2 inches long. They're the biggest screw that I can fit right here and right here on either side of this channel that has been cut for the cleaning rod to go through. I'm going to drill two oversized holes here and here, and I'm going to put these screws on either side, and then I'm going to glass bed those in either side of this rifle stock, and that's going to tie these two ends together. Now the glass bedding, it seeps into wood. So what I'm going to do is I'm going to drill these holes, I'm going to pack them with glass bedding, I'm even going to put two little air escape holes on either side here inside the barrel channel so that they can totally squeeze out, so that this glass bedding can come completely out of those air holes I'm going to put up here hidden in the barrel channel. And they will completely encapsulate these screws, they'll sink into the wood, and they will hold, due to the aggressive threading on these screws, that will create your mechanical bond, keeping this from moving either way. So I'm going to have to cut the heads off of those screws, drill some oversized holes, because I'll never be able to get these holes on either side to perfectly match up. They need to be slightly oversized so I can play these together and finally get them to snug up perfectly. And then once I'm able to do that, I'm going to put the barreled action in this thing, probably with like a sheet of saran wrap on between the glass bedding in the barrel channel and the actual barrel, so I don't cement the barrel into the action, or excuse me, the barrel into the stock. And I'll use that as a big straight mandrel. And what that'll do is that'll keep everything straight, everything just as it should be, and I'll wrap it up with tape or with tubing or something to hold it all together. and I'll let that set for a couple days, because this Acroglass is really good stuff. It just takes a while to set, and you know, all good things come with patience. So I'm going to put that over there. The first thing I'm going to have to do is cut these screws so that I can just get that out of the way. And then, then the next thing I'm going to have to do is going to have to be drilling the holes, the 4 holes that correspond with each other in these 2 respective pieces of wood. And that will have the clinch factor. I need to make sure that's done correctly. And for anybody wondering about how it's going to look up underneath the barrel channel, as you can see, I'd already put some glass bedding in there to try to tie these 2 together, and that was the only thing that held these 2 guys together until that actual piece of metal snapped. I wasn't the one who made the decision to screw up this rifle stock. All I can do is do a repair that nobody knows is there unless they pull this rifle apart and take a look. I'm already 80% of the way there with having made that piece of walnut that fits in there. It is still strongly attached, and once I run these 2 screws through about that much of this inner stock, this guy will be ready to go, and he'll hopefully be able to take some recoil, because I want this rifle to be able to fire. It's a gun. It's not sitting on a museum shelf somewhere. This is a live firearm that I want to be able to shoot if I so choose, and I also want it strong enough that if it's dropped, something happens to it, it's going to be able to withstand that. So hopefully this will work out. Alright, so I mentioned earlier that the real pucker factor for this repair is going to be drilling the 2 holes that these screws are going to need to go into. 4 holes, because there's going to be 2 in each side to create 2 channels that for the most part meet up. Now this is going to be difficult because let's just do a quick. This is an exaggeration, folks, but what this is the inner cross section of the fore end and the rest of the stock. So as you can see, there's this cutout on top for the barrel to rest in, and it kind of creates this U shape. So in the middle here is the channel that the cleaning rod goes through, and that needs to remain unobstructed. But and I have that handled for the most part. I know what I'm going to do. But really, the problem is the amount of wood that's left here and here on either side of the channel where this U is thickest, here and here. What's the biggest hole I can get away with comfortably drilling? Because there's no way I'm going to be able to chuck this up into my drill press with the tools I have to be able to assure that this is going to be straight up and down in alignment with the drill bit. So this is going to have to be by hand. So I'm going to have to take my time with it. So I did my homework, and just by holding drill bits up to the piece of wood I'm talking about here and here, I found out that this drill bit, which is coincidentally the same diameter that the hole the cleaning rod goes through, this is the guy. This is the one that I'm going to be using, and I found I'm going to be putting a hole here and here on each side. Now this is the problem. Let's create another diagram here. Here's my two fore ends. This is the fore end. And let's just say this is the rest of the stock. How am I going to make sure that these holes match up? I can't. I mechanically am not able to achieve that precision with the equipment I have. And I guarantee 99% of the people watching this video are unable to do that as well, because not everybody has expensive wood mills, expensive equipment. It's always entertaining to me when guys do so-called tutorials and they say, okay, let's go over to my $10,000 mill or my $5,000 mill and just do this easy peasy, quick and easy. Well, guess what? Not everybody has even the tools I have, and I have a hand drill and a drill press and some other rotary tools I've been able to buy over the years. So how am I going to do that? Well, I'm going to have to make a compromise. I'm not going to be able to drill holes that actually engage this threading. I'm not going to be able to drill holes that are small enough for this threading to bite into the wood. I'm only going to be able to drill holes. This is just bigger than this screw. So when this screw goes into the hole, draw another diagram for you. When this screw goes down into this hole, there's going to be a little bit of slop. There's going to be a little bit of play for that screw to meet up with the other side. I'm not perfect. I don't have perfect tools, but I can get it close enough with patience and checking and triple checking and quadruple checking that these two holes are close enough so that the allowed amount of slop between them will get it to align, and then cinch these two up together. I have a lot going for me here. I still have the little nubbins of the dog bone that's left up there, and as you can see, these actually cinch themselves up perfectly to where they're supposed to be pretty much on their own. Not to mention when the barreled action's in there and it's all tied together. So there's a lot going for this project that's already wanting to put it right in the perfect place. I did some of the proper work the first time around, but this time I just need to do it properly. So these holes, 1, 2, 3, 4, they need to be in the correct place on the stock so they don't either smash out of the side of the stock, that would be disgusting and catastrophic, or B, block the hole that runs the lengthwise of this stock that carries the cleaning rod. So there's a very small tolerance right in there where I'm able to make that hole happen. So the hole needs to be pretty straight up and down the length of this stock so it doesn't blow out on either side, or up into the channel here, I forgot. So there's a really small tolerance. And then also, these holes need to correspond together well enough that I can make this happen. So as you can see, this is why this guy has pucker factor. Alright, so what I got here is a scrap piece of wood. This is just some old fur I have in the corner. And what I did was I chalked this up into my drill press and I just quickly ran a hole into it with this drill bit. And I wanted to test that if I put these screws that I prepared, I was pretty sure this would happen. I just wanted to make sure because once I start eating that walnut, there's no going back. But here I am. I made this test hole, and this screw, it's going to be 50-50. 50% in one piece, 50% in the other piece. I'm going to cinch it about 50% of the way down. There's a lot of slop going in there. Let's see if I can show this to you. And let's take a look. Yeah, look at that. Look at how much play there is in this guy. He can move about a millimeter, 2 millimeters almost, in every direction. And this fur is really soft, but with it in there about halfway, it has quite a bit of play. So even if these guys are off by a millimeter or so, I'm able to get them together and glass bed these screws on either side. So this confirmed for me that there is a certain amount of play that can get these holes to cinch up together, like I showed you in my handy dandy diagram. Let's just go in there. I'm not gonna drill this at once, just so you guys know. This is not gonna happen. First, what I'm gonna do is I am going to walk that hole for this guy all the way up from the smallest drill bit I have all the way up until I finally get the hole where I want it, because this allows me more control, infinitely more control than if I just went in there and blasted that hole out with this guy. And we're just going to slowly eat away at the hole until they get exactly where I want them. But first, I need to figure out where I'm going to put the holes exactly on this rifle stock.